looking at different options for the Wi-Fi mesh around the property, and I've been mostly playing around with the ESP8266. This is the O1S version. In fact, it's a modified O1S version because this flash chip here is a 4 meg, not the 1 meg that it comes with. So this has just had a brain transplant, and I'll link up to how I did that in a previous video. Now, a sensible person would use one of these development boards for the ESP8266 or one of these development boards for the ESP32. But I actually started with the bare chip, something along this line. I think this one is a 12S, but I've got, 07Ss, 12Es, 12Fs, even, there's a whole range of these things. And what I used to do was put them on these boards, and you can see what a hot mess it is because, having to then try and put that on a breadboard or use it in some way is quite difficult. I mean, not bad, but this is going back a couple of years now. And then, of course, programming, you had wires everywhere and pull up this and pull down that, so that was a bit of an issue. I was pretty pleased recently to take delivery of these guys here. So these are little programmers. This is for the ESP32, and this is for the ESP8266. And they've got these weird pins, which I'll try and get a close-up of. And the pins are, they're sort of folded, I guess, or it's almost there, yep. So you can sort of see them, they're sort of folded over. It's quite strange looking. And what they do is that they hug the actual chip itself. So it just sits in here, and it gets hugged by those. And then you can then plug that into your computer, and here we go. So it's just settled in there. And then you can just connect up to it as per normal. I'm presuming it's a CH340 chip or something similar to do the serial. You've got your reset, you've got your pull, your reboot, all sorts of little buttons all over the place. It's fantastic. And what it allows you to do is to program it pretty easily. So no more wires sort of splayed all over the place and second guessing whether or not the breadboard's working and that sort of stuff. This is a pretty good development. And same with this is the ESP32. I think this is the 32S, so it actually fits into there. But the normal 32s fit in there and can be programmed as well. Now, once they're programmed, one of my goals is to try and make the reprogramming of them over the air. And that's where the extra flash comes in handy too for doing it over the air, because you can reserve a little bit for over the air reprogramming. And I want to do a bit of playing with that with these chips first to sort of, to get some idea of how that works or even whether it does work. To do that, rather than putting on this sort of old style board, I've got a couple of options. I did my own version based on something I saw online. And so this is for an ESP07 or in this case 12 or what have you. And it's just broken out. I think the only extra thing I put on there was a pull-up resistor for reset, but everything else is pretty standard. There is a lot online about the things that you need around here in order to make a fully functioning ESP8266. So there's capacitors and resistors and all that sort of stuff. So it's going to be interesting also to see what I need and whether this board will need any further development to put those sorts of things on there. But also at around the same time, this arrived. So this is a commercial-ish version of it, so something I got off AliExpress. And you can see it's a bit of a breakout board for the ESP, let's say 07 or 12 on one side, but you've got your ESP32 on the other. Pretty cool. There's a region down here I don't quite understand what's going on, whether or not the work experience kid did this one, and you can see that there's three holes here which sort of don't line up or match up. Not too fussed by that, but just the idea that you throw something on there and then you can program it over the air is what I'm looking for. So the plan for this one is to solder these up, so program them as over the air, solder them up, and then see if we can't do something like, obviously, blink an LED, because that's what it's all about. So yeah, let's do that. So I do have a fan going in the background, but I can fix that with Audacity. There we go. And if you do spot a solder burn on my hand, forgive me. Lack of sleep because of Christmas puppies caused me to be a little careless the other day. I suppose it's a good lesson in just making sure that, you don't forget that these things are at 300 and something degrees. It didn't hurt that much. because it's pretty instant cauterization, but then later on you do have it blistering, and then it's important to get some betadine or something on it because you know, your skin is your anti-infection coverage, and if you breach that, then that's when the nasties can get in. And yeah, once again with puppies, you know, let's just say hygiene isn't high on their list, but fun is, you know, at 3 in the morning. So yeah, I blame lack of sleep. It's the first solder burn that I've had in I don't know how long, maybe a couple of years, I guess. So yeah, not good. Anyway, I'll try and keep it out of your focus so as not to freak you out. So yeah, just put these header pins on. So a smart person would have gone with the commercial guy first in terms of the adapter, but I don't know if you've ever made yourself a PCB, but it's pretty exciting when it comes in. The first thing you want to do is solder it up and see if you got it right, because if you didn't, it's a bit of a bummer. Well, that's where the second and third and fourth and 15th revisions come from. That looks pretty good. Maybe this guy a little bit more. Nice. So these are all castellated. So in terms of how to do this, I'm thinking maybe do one pad first. So let's do that. This is a nice thick pad, so I'll use that guy for number one. And then if I can slot that in, the rest should be pretty straightforward. Yep, so let's push him over. A little bit more. Yeah, it looks lined up pretty well. Maybe needs to go a little bit forward so I can get those back pads okay. Oh, having said that about the back pads, this is the 12S, which doesn't have the back pads, I don't think. So it's just the side ones we're looking for. This will be interesting. All right, let's get these other guys all lined up and solder it up. Looks like I'm getting to the end of the solder. All right, here we go. I'll clean that tip up. The irony is if I'm not filming, this goes a lot smoother. But I'm trying to get my big buffet out of the road. On this channel, we've seen way too much of my hair covering up the camera. It's just a little iPad which is hovering over the workbench, so yeah, I do tend to get my buffet in there a bit too often. Speaking of the channel, I have to say, I'm pretty happy, there's a bridge, with the number of people that come and visit. So whether you're a first-time visitor or a repeat offender, thank you. Much appreciated. I know I'm supposed to say don't forget to hit like and subscribe, but what the hell, you do what you want to do. You do you, as they say. This one's a bit tricky, this last one. Come on, where's that pad? Yeah, that looks good. I'll get a couple of pictures close up and we can see how clean those are. Pretty keen to try this. So already the revisions are in, mainly because the pins facing down have the actual labels on them. You can't see them from the top, so you've sort of got to, work that out, I guess. So anyway, if I've got this right, that should be VCC coming in. So if we mirror this across, flip that across that way, so it is the fourth one along, which it is, and then on the other side, ground is the fourth one along as well. And my GPIO4, is mislabeled for the 12S. I think it's actually the fourth one along, but we'll find out, I suppose. So first thing is to get some power to it and see if it blows up. No, I did see a little light go on there, so I presume that's good news. Let's go with the label first. That's GPIO4 is the third one along. I wasn't too confident about that. Because they're all slightly different, this is the 12S version. So I'll actually overlay the pinout up here so you can see what's going on. It's actually, I think, the next one along. Yeah, okay, well that's good. All right, nice one. So the final thing now to do is to change the code over the air. So I'll fire up the computer down here, see if I can make a connection to it and do that. That'd be pretty cool. I'm going to try and connect this up to the internet so that, well, I can program it. So at the moment, it's been programmed to blink once a second just for 50 microseconds. But I'm just capturing the Arduino ID as well, and I've changed the rate of blinking here so that it's actually on for 1 second and off for 1 second. And the other thing is that you can see down here where it says port. It's actually the name of the device, which I've called Blinky OTA, or over the air, and it's got a local address as well. Just a couple of things to note about this. There's three things that I learnt through this process. One is that the generic 12S that I bought supposedly comes with 4 megabytes of RAM, but this one actually, when polled, only comes with 1 megabyte of RAM, so it just whites out for that. I mean, I'll probably pull the cap on this and replace it anyway, but that's a bit of a nonsense. So that was a bit frustrating. Another thing is that you need a good source of power. So this is hooked up to my power supply, and it was, I don't know, somewhere around the 150 milliamp in current limiting, and it actually tripped it, and it was freaking me out because I thought maybe I'd made some sort of soldering mistake on this, and there was some sort of short. But in fact, when it accesses the internet, it needs a bit of grunt. And in fact, the router for my system is upstairs, and so I need to actually put a repeater down here to make this easier. So a good source of power is necessary, good local source of Wi-Fi for over-the-air programming, and just be careful about that those 12S's you get online, because this one from an AliExpress seller is not all that it's cut out to be. All right, so the next thing to do is to compile this and load it up. Now that process can take a minute and a half the first time, so I might speed this bit up, and we'll come back for when it's actually uploading. And we're about back for uploading, and you can see that process is working fine. The ESP12S goes to sleep, and then it should come back with a strong blink of 1 second on and 1 second off. There it goes. And that's over the air programming, folks. It's a miracle, but it does require a bit of fiddling around. So yeah, that is the circuit working for this week. It's it was frustrating at times, but very pleasing to see it all work out in the end. And I like the little adapter board, and hopefully we'll keep using that. And I'm keen now to try the other one, the commercial one, and we'll try it with the ESP32. See you next time.